All right, so good evening, everyone. Just confirm you're able to hear clearly and you can see the screen.
Yes, sir.
Yes, sir.
All right,
Yeah.
great. So I have a recording for you from last week. Has not been released as yet. It will be released soon, but I need to get an indication of what has been happening. So there were 4 recordings that were made available. So please raise your hand to indicate that you have watched all 4. If you're not addressing me, please put your mics on mute. That's 6 out of 20 odd. All right, that's 7 out of 27. That's bad, folks. It's awful as a matter of fact.
You mean the YouTube video?
Yeah, man, there are 4 videos that I gave to watch.
He posts YouTube videos to watch before class.
I'm not hearing if that was for me.
Yep.
Yeah, so 9 out of 28. That's still awful, folks. So I don't know what to say. How are you going to appreciate the content if you don't watch the video? Yeah, we're having a conversation now, you know. So how are you going to appreciate if you don't watch the videos? I just can put down the hands now, folks. I think I'm wasting my time. Because if I sit down and trying to record the videos before time, so that you can have an advantage when you come to the class and when you're not going to watch it, then I'm going to stop. And we just come and we do whatever we can do during the class time and we call it a day.
Sir, I only watched the first 2 videos from the first week you told us to watch them. I didn't know you uploaded anymore.
Went through this last week. They were not showing, and I
I
make sure I
wasn't
put
here
them in
last week, that's why.
and I make sure, no, but you could have checked back, brother. You could have checked back and you'd have say 4 now instead of 2. As students, we don't have a responsibility, you know. I have a responsibility to deliver the content. You have a responsibility to interact with the content so that you get the knowledge. And I'm talking to the entire class. Because you know what happened? When we teachers don't show up for class, you quick to say, boy, we not show up and send around one bag of message and say, boy, teacher not show up. So if the effort is being put into creating content for you, then you need to be interacting with the content. It cannot be that, well, within a week 3, you have 4 videos, 4 recordings, and 9 out of 28 person at the time when I last saw it indicate that them watch all 4. That is totally unacceptable. Anyway, moving on. Got the A don't give out themselves, you know. Yeah. Everybody can get an A. We're going to have to work for that A. It not going to give out free. If you don't do what you need to do, then whatever grade you get, I mean, that's what you did once. That's what you work for. All right, moving on. We're going to create a network on the fly for those who would have interacted with the material then it's supposed to make sense to you. I'm going to ask you to assist me in terms of creating this network. So I want to grab two machines. I want to put them on a switch. And I want to ensure that they can communicate with each other. I'm going to do that in this environment, the simulator. And we want to ensure that the connectivity between both devices are actually up and running. So raise your hand. I'll acknowledge you. You unmute your mic. And kind of give me some ideas as to how we are going to proceed. Go ahead, Azan.
Yes, sir. Good evening. So, well, sir, based on my knowledge so far, it depends on how you want to configure those two devices on a switch. Now, sir, if it's a layer 2 switch, then that would mean they're being configured on a LAN network or something of the sort. And then, no, sir, you can either configure them by static IP addresses or by...
1 minute, Azan. A demonstration we're doing. So more, you tell me what to do below this network. We can all see it in operation. That's what I'm asking.
Oh, okay, sir. All right. So first thing, you would go to the devices section and select a 2911 switch, sir.
So devices section, you're talking devices and devices,
Yes, sir.
or you're talking network devices? Which one of them?
Basically, switches. The network devices, sir, and then you click on the switch port, sir, on the router port right now, sir. And then you'd select the 2911 switch.
I'm not seeing a 2911.
2911. Oh, my bad, sir. That's actually a router number 2960, sir.
2960.
Yes,
All
sir.
right.
And then from there on out, you would select two PCs from the devices section, sir.
Which devices? There are
Um,
two things here that's the devices. So which devices?
the other one, sir, not the one they're on right now.
The end devices.
End devices, yes, sir. And then sir, I look like you're one a bit different from mine. I'm not sure the PC them.
Maybe you can scroll.
Oh, yes, sir. Yeah, that. So so you would drag up two PCs close to the switch, sir. And now what you can do, you click on that lightning like icon to go into the connections. No, sir. Right here, so I found that.
All right, 1 minute, 1 minute. So
Yes, sir.
may I give Kahil a chance now?
All right, sir.
Right, because he's on WhatsApp. So thanks, Azan. You
Yes,
carry
sir.
to a good part. Yes,
All right,
Kahil. Go on now. Is it Kahil or Kahil?
Hi, you, sir.
All right, Kahil. Yeah, talk to you now. Connections.
Yeah, so we would use I think the copper crossover.
Copper crossover. All right, so this one.
No,
Right.
no, the one to the copper straight through.
This one.
Yes, sir.
Copper crossover. Yeah.
And then you would press the router.
This which router?
Oh, the 2960.
Is that a router?
The switch, sir.
Please mute your mic.
Sorry about that.
The switch, sir. My bad.
Oh, so yeah, what you say now?
Yeah, we press on the switch and
Press on the switch.
connect it. Or fast Ethernet.
Fast Ethernet.
And connect it to PC1 and then
Take it to PC1.
PC0. Yeah, fast Ethernet again.
Alright.
And then you connect the other one to
Let me connect the other one. All right, thanks very much. All right, Siobhan, I see your hand.
Sir, just a question though. If I recall correctly, do we really need a switch if we're trying to communicate between two PCs?
All right, so the question to the class, do we need a switch if we're trying to communicate between two PCs? What are your thoughts?
So I know there's wireless, like
No, we're talking
Bluetooth.
about wired connection.
Oh yes,
Wireless.
yes, you would need us.
Sir, why couldn't we just use the wires, sir? Based on the crossover wires, why couldn't we just use that?
Why couldn't we just use what?
The crossover wires only.
The crossover wires only? What do you mean?
Between the two, the same wires here,
Yeah.
cable. Why
Yeah.
couldn't we just use that if you're trying to communicate with them?
All right, so
Based on it.
I still asking the class the question. I don't know the answer to that. So the class going to answer that. Go ahead. All right, I'm going to allow Scott to go this time. Go ahead, Scott.
Sir, if you were just connecting the two PCs, then you could just use the crossover cable, or you would use the crossover cable, but because you said you're trying to build out a network, then you're going to need the switch to be able to connect more than just the two PCs.
All right, very good. Thanks for that, Scott. So there's the answer, Shaban. I did indicate that we're building out a network. And I'm starting with two PCs, but the network can grow. So I might end up with 10 PCs. So it makes sense for us to design the architecture so that it can scale, it can grow. And if we are going to connect up each of the devices together straight, then that's not going to be scalable. Because it means that for every machine, we're going to need to have in multiple NICs. What's a NIC, Claire?
Network interface card.
It's a network interface card. Good. So it means that
Sir,
we're going to need multiple network interface cards so that we can
just a
connect up.
question. Would it be wrong
I can finish.
Sorry.
Yeah, man. So what we're saying is that if we are going to be connecting all of these machines together straight, peer-to-peer, then we're going to require multiple NICs so that we can foster the communication between a device and several other devices. When we use a switch, it minimizes the amount of NICs that we are going to need, because remember, the switch is going to come with NICs. That's why we end up having these ports. All right? And it's also going to streamline the communication, as we're going to talk about a little bit later. Yes, Azan.
Yes, sir. So, I'm wondering something. When you say for all devices you have to communicate with each other, you would need multiple NICs. Now, since each port on a switch acts as a sort of broadcast
No,
medium.
hold on. You have to take what I said in context. A question was asked a while ago, and I answered that question in a particular context. So the question was asked, can't we just connect up the machines directly to each other? And I'm answering in that context. So in that context, there's no switch.
Oh, okay, sir.
All right?
Oh, well, I guess my question is a bit different, sir. What I'm really asking is that are NICs and VLANs the same thing, sir?
No, they are not the same thing. So we don't,
Oh, okay.
we're not talking about VLAN.
All
We're
right, sir.
talking about NICs, network interface card. Network interface card are going to have those ports, those slots that allow us to connect the RJ45 cable into the device. Yes, Stephen.
I just wanted to try after Scott is finished.
I think Scott finished. Right, Scott?
Yes, sir.
Come on, Scott finished. So what you trying now?
Okay, so I just want to try one of the PCs. I'm new to Cisco Pocket Tracer. So
No,
the
man,
first
you can't. I've been here since day one, don't
Yeah.
come on.
All right. So the
All right.
first thing I'm thinking is we turn on. Let's just do. I have PC 0 and PC 1. So first, I'm gonna turn on PC 0. So click on. Sorry. Can you hear me?
Yeah, man, but them already on.
Okay. All right. So now that it's on,
Yeah, man. So
so
tell
we're
me
gonna
about
check.
PC one because them already tell me about PCs. So tell me about PC one. What they going to
Tell
do?
you. All right. So we're gonna check for the IP address and the MAC address. So
Oh,
we're gonna.
we not reach there, so yeah.
Oh.
Yeah.
Okay. Oh, sorry. The connection. Is that
Yeah,
what you're
we'll
talking
just
about?
deal with the connection
Okay.
first.
Sorry. I didn't realize that wasn't
Yeah.
done. So we're
If we
gonna go.
don't 1 minute, if we don't connect it, we could have put IP address from now till next year, not true?
True. Yeah.
Yeah. Mm-hmm.
So I'm thinking we do another copper crossover. So click on the copper crossover and click on the switch. And we're gonna do fast Ethernet 2. And then click on PC 1 and the fast Ethernet 0.
All right.
And mhm,
All right, so
that's
thanks. So I have some
you're welcome.
question I need to ask the class now. When do we use a crossover cable? Go ahead, Scott.
Sir,
Say your hand.
sir, when you're connecting like devices
When we're
or devices of the
connecting
same type.
devices that belong to the same. Good. So PC to PC, we use a crossover cable, right?
Yes, sir.
Yeah, because they belong to the same family. So what about a PC and a switch? Are they in the same family? That's a question to the class.
Yes, because of how the receiving and the transmitting port. I don't remember if it was in the video or if it was in class that you said it. Depending like the port, they receive and
You're saying yes.
yes.
All right. So who else agree that is yes? Or does anyone have a different viewpoint?
Sorry, sir, not a switch. I meant a router, PC and a router. That's what I meant to say.
All right, a switch we're talking about now though. The
Sir?
question is a switch and a PC in the same family? That's the question.
Sir, can you hear me, sir?
Yes, I hear you, Kimberly.
I don't think it's in the same family. I
You
think
don't
these
think
are
or you know?
they're not in the same family. I think this the
Oh,
PC
you
and the
sure?
switches the PC and the switches can be connected to form one network but they serve different roles.
Yeah, but are they in the same family?
No, sir. No.
Sure. I will go
Sir.
vote now, you know. Yeah, man, we're gonna vote, man.
Sir, I said no, sir.
Yeah, man, you say no. And Steven say yes.
Okay,
We'll
sir.
vote.
What's the verdict?
We're going to vote. I'm going to see what going in the class. So all those who believe that the PC and the switch are in the same family, raise your hand. All right, so 2% out of 39. Thank you. All those who believe that the PC and the switch are in different families, raise your hand. So that's 14. That's 17 out of the 39. All right. So that's couple more. Some people can't raise them hand. So them put it in the chat. All right. So but Steven, I'm say I vote 2 times.
Because it was a mistake. It was a mistake at first. So what I meant to say was the port that the PC would receive and transmit data on are different ports than the switch would receive and transmit data on.
All right, you keep saying ports, not ports, it's
What do you call
pins.
it? Yes, sorry, that's what I meant. Yes.
Pins, yeah.
Mhm.
I'm gonna put all of them things up on some multiple choice tests, you know. Who pay attention and who not pay attention and who watch the video them and who not watch the video them. So therefore, if it is that the PC and the switch are in different families, then what kind of cable we're supposed to be using?
So you're supposed to be using the straight cable.
We're supposed to be using straight through. Yeah, so why are we using a crossover here, sir? Yeah, so that's something that we need to ponder out. Because when they tell me straight through, when they tell me crossover, no, sir?
Yes, sir. So we draw for a crossover because the PC receives data on pin 1 and pin 2, and the switch so the switch received data from the computer. Oh, I think I get.
No, man.
Sir?
So what you're saying, you have to make up your mind and say
Okay.
one thing.
All right,
We should
so
connect
the
them using 1 minute. Hear the question. Should we connect the PC and the switch with a crossover cable or a straight through cable? What's the answer, Stephen?
with a crossover, because the 4 pins that are in the RJ45 connector are you have 1, 2, 3, and 6 based on what you said in the video, right? And the PC transmits data on pin 1 and pin 2. The switch, sorry, transmits data on pin 1 and pin 2. The PC receives data on pin 3 and pin 6.
I think you complicate the issue.
Okay.
And you might end up confuse yourself. I gotta ask you a simple question. Okay. Anybody actually saying it in the chat? If the devices are similar, what kind of cable we use? Crossover. So the question then is a switch and a PC, are they similar devices? Yes or no? Type in the chat, folks. Let me go to the question again. Is a switch and a PC similar devices? Do they belong to the same family? I'm seeing most people saying no. So if they are not in the same family, then what kind of cable are we going to use to connect them?
Straight through.
Straight through cable. All right. So you don't have to think about pin 1 and pin 2 and pin 3 and pin 6 right now. If that are confusing. The rule of thumb is similar devices, crossover cable. If they are not similar, straight through. And I think in the recording, you should have seen a table that tell you which ones are in the same family. So there you go. Yes, folks, yes or no?
Yes, sir.
All right, good. Excellent. So it's important that we watch the recordings. It's important because it is that information that we use it. So I've put another switch there, and I'm going to quickly throw on crossover. And right away, as we put them on, you see that it's red up. Meaning, wrong cable. That's the crossover, don't? Going back to the switch, don't? Yeah, crossover cable, going to the switch. Not working. Let me use a straight through cable.
Sir, question.
Notice, 1 minute, 1 minute, 1 minute. Notice that as we put it on, it starts to get green. And now the switch is waiting for the communication to take place for it to be fully green. So just by virtue of what we're seeing on the screen, we realize that, all right, the crossover cable cannot work. All right, who had a question?
Me. I
Yeah,
already
go ahead.
mentioned something about scalability.
Yes.
Like, based on the model that we have on screen now, I fail to understand, like, how would we scale this?
Simple. Grab a machine. What scalability mean to you? Let me ask that first.
Scale means it get bigger.
All right, yeah. So we can easily add machines or remove machines. So how simple is it to add a machine? Well, we grab a PC, grab a cable, attach the cable to the PC, attach the cable to the switch. Just by doing that, we have added another machine. All we have to do now is go and configure it from a layer 3 perspective, from an IP perspective, so that them can communicate. And this switch happens to have about 24 ports. So if you look on the listing there, you see it go down from 1 straight down to 24. So this switch have 24 ports, which means this switch can support 24 machines connected.
Okay.
All right, so let me take the hands in the way that I see them. Azan and then Scott.
Yes, sir. Well, I was gonna add something in terms of scalability being explained, sir. So basically, it's the ability of having an existing network and you're able to add more devices without affecting the original network infrastructure, right, sir?
That's correct.
All right, sir. So apart from within the LAN like connection like what we're basically constructing right now, sir, how much ports would a layer 3 switch or a multi-switch have, sir?
Every switch can have different number of ports.
All right,
So
sir.
you buy a switch based on the amount of ports you want and the amount of ports it's. Go ahead, Scott.
Okay, sir. So I know that we're not supposed to use the crossover cable, but I wanted to know why is it that if it's wrong, it's green in the first diagram?
That's an
And the
excellent
first-
question, Scott. Excellent question. And so we can address that question. So if you look at the model numbers, one is 2950 and one is 2960. So which one created first? Which one I think created first?
The 2950, sir.
2950. So the 2950 is what an original switch is actually going to do. But you know how we humans are. We like to improve things as time go by. So we have created different types of switches that are now a little bit more intelligent, meaning you can connect it with either a straight through or a crossover, and it will detect the type of cable and make the necessary adjustments so that you can communicate properly. So that's why in my demonstration, I want to use the 2950. And I think that's what I would have done last week, because that truly demonstrates how a real original switch works. You got that? So now most of the devices that you are going to have in organizations, if they are newer devices, any one of the cable that you plug in will tend to work because the device will auto-configure itself to recognize that type of cable and use it appropriately. I hope that makes sense to you, Scott.
Yes, sir, it does.
Good. Yes, Stephen.
Sir, where the confusion comes in for me is when you ask the question directly in class here, you know, it's easy to pick the answer. But in the video, you did say devices that transmit and receive on the same the same pins are the same or similar, and devices that don't are different. So that's where the confusion kind of came up for me. And then you gave an example in the video as well. I was just saying, like, I get what you're saying, but I was just saying that's where it kind of get confusing for me a little bit.
Yeah, but devices that transmit on the same pins are in the same family. If I said something else in the video, then that would have been an error.
Okay.
Yeah. So devices that transmit on the same pins are in the same family. So a PC is going to transmit on pins 1 and 2. And that is why if we are going to tie them together directly, we need to cross the cable over so that the transmit of one goes to the receive of the other.
All right, so let me tell you what I saw in the video. So the PC transmit on
1 minute.
Okay.
Whatever is in the video, if it's wrong, it's wrong. I'm clarifying no. So once you understand what I'm saying, no,
Okay.
then we're good. So if
All
there's
right.
an error in the video, then we address that and we'll move forward. So class, if it is that the devices transmit on the same pins, then they are in the same family. I hope we're good with that. Go ahead, Russell.
Yes, sir. I was saying, so two questions rather. The first one, would you recommend just as a default, just use the right cables regardless of if the switch is
Absolutely.
connected?
That is why I'm going to go through the trouble of telling you about it.
All right, cool.
Because,
Second question.
because when you go into an organization, you're not guaranteed to only find new switches in there.
Mm-hmm.
Yeah.
I figured
So
as
you
much.
have to know or you can navigate. If when you look, you realize that boy, this is a whole switch. So the rule of thumb is you must know that for switches to PC, you're going to use a straight through cable. And that's what you should be using. Second question.
All right, so for the second question, sorry, since it's doing data conversion, does that necessarily mean that it's going to make the network somewhat slower? So say, for example,
That's a good question. I think
it's
it's going to be
technical.
negligible.
Oh, so it does be slower, but not at a rate that you can really identify.
Yeah, it might be a little bit slower, but yeah, it's going to be negligible. Because, yeah, there's going to be some conversion. So that conversion must come at some cost. But it's going to be negligible.
All right.
All right. Yes, Azan.
Yes, sir. Well, question, sir. In terms of a network becoming slower, does it is it factored by things like the scalability of the network, the capability of the network to transmit and receive data at the same time in real time and stuff like that, sir?
What heap of things it depends on. But that's beyond what we're trying to accomplish, right?
All right, sir.
Yeah, go for it. So let me remove this cable and put on the right cable. All right, good. So we have configured that switch. Let me bring it into the middle of the picture. And now we want to ensure that PC2 can talk to PC4. So what do I now need to do? Raise your hand again so I can acknowledge you, and then you just unmute and walk us through. Go ahead, Kahil.
All right, sir. So first you would click on the PC.
I click on the PC.
Yes, sir.
Come on,
So
you're seeing it, right?
no, sir.
You're not seeing it? All right. Give me a minute, let me stop and reshare. Click on the PC. You seeing it now?
Yes, sir. So
right,
you'd
cool.
go on desktop.
Desktop.
And then you go in IP configuration.
IP configuration.
And you assign it address on the IPv4.
All right, so on the IPv4, we're giving it an address, and it's going to be a static address, meaning we're putting it in manually. So I'm going to use 192.168.75.3.
True. Okay, sir. Then you would go back onto desktop.
Back onto desktop.
And then come out of desktop and add IP address to the others as well.
Okay, so we need to put on IP addresses on the others. So let's go back to IP config. That's the IP address. Please note it, because when you need to tell me what kind of addresses I'm going to use on the other one. So once you have noted this IP address, just type N in the chat. All right, so we're seeing some responses. Great. So I can get rid of this. All right, so we need to configure this one.
Yes, sir.
I'm going to desktop, and I need somebody else apart from Cahill now to tell me what I'm going to type. All right, so I'm seeing some hands. Just give me a minute. I said apart from Cahill, so Russell, go ahead.
All right, sir. So the first one, all right, so we can just put for this one, sir, 192.
192.
Dot 168.
168.
Dot 75. Dot
75.
Dot 5.
5. All right. And somebody else now, apart from Russell and Cahill.
Oh wait, sir, that was PC3, not PC4. Oh.
That was PC3.
Oh, sir, I thought that was PC4. That's why oh, all right.
No matter.
Never mind. I guess we can still make it work. I thought it was PC4.
No, that's fine.
All right.
Dejan, go ahead.
Yes. So for that one you can put 192.
192.
168.
168. 75. That what?
8.
8. All right. I notice all of you are using 192.168.75. Why not 192.168.76? I think 76 is a better number than 75, so I'm not sticking with 192.168.75. Now, if you answer quickly, how we so out of time.
There, because those three numbers are the numbers that are used to identify the network itself.
And how you come to that conclusion?
Sir, because in the subnet mask, if you notice, the three numbers in the three spots, you have 255, which means that those three numbers are used by the network or used to identify the network.
All right, thank you very much, Scott. So we need to look at the subnet mask. And the simple way is once we see the number 255 under that column, then it means that that number of the IP address is going to be associated with the network ID. Now, I think I've said this several times. So I hope that it finally resonates with everybody. And those who don't watch the video, them only need to go about. All right. So I think we have IP address on all of them. Now, we want to see if PC2 can communicate with PC4. So who can walk me through doing that? Apart from Cahill, we want some more people, whole lot more people in our class. I respect the contribution, Cahill, but may I try to wake up the other people then.
Sir, you would ping the PC.
Oh, so how would do that, Kyle? You have to tell me how I'm gonna do that.
You go into you click on the PC.
Click on the PC.
Go into command prompt.
Go into command prompt.
Or go again.
I would say
Something
Yankee
that
Doodle
can
went to town.
be.
I would say Abracadabra.
I don't fully remember, sir, when I tell that.
All right, kind of fully remember. Somebody is apart from Russell. Once again, thanks for your contribution. And apart from Kahil.
Sir.
And apart from, yeah, Ricardo. Yeah, me see one, Ricardo.
Yes, sir.
Yeah, man, tell me what to do.
Sir, you type ping
Ping,
space then
space,
192
192,
168
168,
75
75,
8.
8. And
And
me could try
enter.
that. All right, me see, like, me I get some reply. Look like that work. All right. So that good. So PC2 communicate with PC4 because PC4 IP address was 192.168.75.8. Yeah, so we just communicated with the PC. All right, wonderful. LK, I saw your hand earlier.
No, sir. It was to answer that ping question.
All right, great. Is that a question now, Russell?
Yes, sir. Is it a case that I have to ping the PCs individually? So, sir, I want
as
to.
opposed to?
No, as opposed to just doing like a single line prompt that does the ping for all the for all the computers, and you see the relevant replies.
Why would you
Similar
want
to
to?
how?
1 minute, 1 minute. Why would you want to ping all the computers at the same time?
All right. So, for example, let's say we just finish up setting up the network for the 2950 under the 2950 switch. So we want to ping all, like, so we had 10 computers and we don't want to go in and ping each and every one with just like one line, and you'll see the relevant replies, and we'll be able to, by the IP address, notify which computer isn't actually replying as it should if it doesn't.
I've
So
never
just
heard
do
of
it in
that.
one go rather than.
I've never heard of that.
Okay.
I won't say it don't exist, but I've never heard of that.
I just wanted
All
to
right?
know. I just wanted to know.
Yeah. All right, good. Now let's go to the switch. And let's go to the command line interface. I think we need to enable the switch. And then we say show MAC address. Spell right? Let's spell address for me. I think that's right. If it's wrong,
sir.
if it's wrong, I am not an English teacher, all right? And what information do you see inside of the MAC address? What this telling you? Go ahead, Russell.
All right, so sorry if I remember correctly, these are for on the MAC address, these are the names for the NICs, for the different PCs.
Say
Like
that again.
the
These are the
8592.
you're kind of cracking up.
Oh, you're not hearing me properly?
It sort of distorted, but go ahead.
All right, sir. So we have underneath the MAC address column, those are the names for the NICs, the network interface cards for
But
each
you
one
said
of
the
the
name
PCs.
for the NICs?
Well, I guess you can say the MAC address or what was assigned.
Okay. So it's the MAC address of the NICs, yes?
Yeah.
All right. Thanks much. I think I saw somebody else who had raised their hand. Who was that person?
Sir, I was gonna say the same thing along with ports that they're connected.
Okay. So you're adding something else.
Yeah.
So,
Along with the ports.
So we have two things. We have the MAC address of the machine, and we have the port of the switch that the machine is connected to. And that is important. So we know that we can send data from the device that is on port 1 straight to the device that is on port 3. And the data goes straight away to that machine because that information is inside the MAC address table. Is this MAC address table missing anything?
Yes, it's missing a device.
Which one?
That would be PC 2, 3, I think, if I remember correctly.
PC who?
3, I think. I'm
All
not
right.
sure.
So let us double check, right? So we go to so if we go, I would just hover over the switch. You will realize that it tells you which one of the ports are in use. Notice it's a up for 1, 2, and 3. I want you to note that, folks. You seeing that, right?
Yes, sir.
No, maybe so.
Yeah.
Yeah. So the switch is telling us that these devices are connected to ports 1, 2, and 3. We can also have a look at the MAC address for a particular machine. So let me go to PC3 as we're saying that that is the one that we're not seeing inside of the list. Go to command prompt. What is the command that will allow me to see the physical address?
IP config, and then I think the backslash and all.
That's the forward slash.
Forward slash, my bad.
And then all. Good. So right here, where it's a physical address, is where we're seeing the physical address or the MAC address for this particular PC, which is PC. So let us also just note the first 3 numbers. I think that should be enough. So that is 0060. And let us go back to our switch. And if we look at the MAC address, we're not seeing 0060, don't it? We're not seeing that one. So it means that that one has not yet give me a second, let me save this. Demo 2. Yeah, so what we're saying is that the information for this has not yet been populated in the switch. Let's try and get it into the switch. You remember what the IP address for PC3 is? If you don't see it right there, 192.168.75.5. So we're going to ping that. So let's go to an arbitrary machine. In this case, it's PC2. And let's ping this one, 192.168.75.5. You ping it, you're getting some responses. Let's go back to the switch. Let's show back the MAC address table. And are you seeing anything new inside of the switch?
Yes, the ports configuration has changed.
All right. So now we're seeing that we have port 1, we have port 2, and we're seeing the MAC address. Yes. So this MAC address table is going to keep on updating. And that's why you see a type here that says dynamic. So each time we communicate with the devices, then the MAC address table is going to be updated. There's something else I want to show you very, very quickly because we're pretty much out of time. I want to go to this machine, PC2, which we have been using. And I'm going to type a command, ARP Right place. Why is this not on? ARP-P. Yes, I'm having an old moment. Just give me 2 seconds, let me figure this out. It is ARP. Why not? Oh. This is my bad. It is -A. And if you look inside the ARP table, we're on PC3. Remember that the IP address for PC3 is .5. It ends with .5. But we had just communicated with PC2, which has an IP address of .3, 192.168.75.3. So as we keep on communicating with machines, there's going to be some information that is going to be stored on the machine itself that will indicate which IP address maps back to which physical address. And this is something that we're going to talk about in our next session so that this becomes clear, because it's a lot of things which are operated so that your devices can communicate on the network. And what we will do next time is we're going to drop a router on this so that we can communicate between 2 different networks. And then we talk about what a LAN is and sort of consolidate the knowledge and bring everything back to a common ground. So, any quick question before we leave? Oh, you know, question. So if you understand what we have gone through, folks, please please indicate in the chat. Then you. All right, great. So most people seem to understand. So I'm going to release both this video and the one previously by about Wednesday. Has to be processed and all of them things. The first, I'll release it, and then you should be good to go. Please, folks, you don't need to watch all of the recordings then. All right, so take care. Wait, 1 minute. I think I see a question. So the switch only shows the active. What do you mean by that, Jada?
Sir, when we were showing the MAC address table, it only showed 2 of the active PCs, the ones that we just pinged.
Right. Yeah, so we do this now, and they're saying what now?
So I was asking if when we show the MAC address table, it's only going to show the 2 active PCs, so the 2 ones that were most recently communicating.
Oh no, it's supposed to have all of them. Oh, that's the question they're asking. Oh, these things can have glitches here. It's a simulator, but typically we have all of them.
Okay, great. Thank you, sir.
Yeah, man. So that answer that. Lost the link to the amazing and informative YouTube channel. It's on the Moodle side. So I don't know how you lose it unless you lose Moodle.
See you next week, sir.
Yeah, man, take care. But the playlist link is on the Moodle side. All right, so that's us for today, folks. So take care.